Hey students, welcome back. In this video we're going to do the study guide for Module 6. This is prepare you guys for the Module 6 assessment. Excuse me. We have this little packet we're going to work through here real quick. Starting at the top left, we have discuss circumcenter. This is the intersection of the three perpendicular bisectors in a triangle. The circumcenter is equidistant to each vertex of the triangle. So these are all going into the side there. They're the perpendicular bisectors. So they split these into two equal pieces. That's why they're all congruent. And because it's perpendicular, it makes a 90-degree angle. Now the sides that are equidistant, or the sides in here that are going to be congruent from this point, are going to be into the angle, the side not drawn. Excuse me, a little sniffly this evening. To the right, we talk about the end center. The end center is the intersection of the three angle bisectors of a triangle. The end center is equidistant to each side. So let's grab this. So here's our end center, and it goes into each angle. Give me just a second here. So it splits this angle into two equal pieces, or two equal sides. It does the same here. That's the whole angle bisector. Remember, bisect. Cut into two equal pieces. So anyway, it's saying that the end center is equidistant to each side. So that means this piece, this piece, and this piece are all, excuse me, sorry, they're all congruent. So it says example. So this is down here. G is the end center, solved for the measure of GC. I was thinking this had to go with this, so let me scoot over here first. So G is the circumcenter of triangle ACE. They want to know what AE is. So I'm going to highlight it. So AE is this whole line. So the way we're going to find that whole line is we're going to use the Pythagorean theorem here to get this side. And because this is the circumcenter, so that means these two sides are congruent. So when we find one, we're going to, so AE, so the whole line is going to be 2 times AF, because both sides are congruent. So we got to do that. So first step, excuse me. One second here to rearrange. So we're going to do this a little quicker, but all right, so we're looking at this little triangle here. Notice that AG here is the hypotenuse, so that's the C. Over here, this is the shortest side, so that's the A. So it's going to be C squared minus B squared equals A squared. C squared minus A squared is going to give us B squared. Excuse me. So this will be 13.1 squared minus 7.2 squared. And B squared is, of course, going to be AF squared. This guy. All right, so we work these out. AF squared is going to be, hang on, sorry. I don't have all the math worked out. Anyway, it ends up being, you take it, after you do this on the calculator, 13.1 squared minus 7.2 squared, and then take the square root of that number. AF is going to be, let me just do that. Excuse me, 10.9. So if we're going 2 times 10.9 for AE, 2 times 10.9 is 21.8. I think I said 4 in class. I was wrong. Excuse me. So 21.8. Excuse me. I apologize. All right. So on the right side there, G is the end center. Solve for GC. So again, I'm just going to highlight these. It makes it a little easier for us to talk about these things. So we're looking for GC. So this line. All right. So let me do a little housekeeping here. So G is the end center. Tells us up here the end center is equidistant from each side. So these are the three sides. So this guy, and this guy are all congruent. So that's 3.9. So this one, I'm sorry, this one is 3.9. So this is our C squared because it's directly across from that 90-degree angle. So that's the hypotenuse. I'm just going to put hype. So A squared plus B squared equals C squared. The A squared is 3.9. The B is 6.4. And C is GC, which what we're looking for here. It's going to be squared. Well, I'm just going to give it to you the way I get it here. So 3.9 squared plus 4.2 squared, and you take the square root of that, GC equals 7.49. We're going to round up to 7.5. Okay, let's scoot up here. All right, bottom of the page. All right, on the left, got the centroid. I've already colored in to kind of save us a little time and shorten our videos. So the centroid, that's the intersection of the three medians of the triangle. The centroid is 2/3 the distance from each vertex to the midpoint of the opposite side. So the side going to the vertex, this is the 2/3. Do these in two. And this side from the centroid to the midpoint of the opposite side is the 1/3. Okay, so they give us the total. If we want the small, we get the 1/3, and notice 1/3 and 2/3. So this side is twice as big as this side. So keep those things in mind. So down here in our example, JKL is our triangle, Q is the centroid, ML. So let me just highlight it. So ML is 45, the whole thing. Well, this is the 2/3 side, QL. So that's your 2/3. And then MQ is your 1/3. So we'll say 45 divided by 3. That's 15. So our small end, MQ, is going to be 15. Now, if this is 1/3, this is 2/3, so this is twice as big. So 15 times 2 is 30. And we'll add them together to make sure 30 plus 15 is 45. The whole thing's 45. Just 1 second. Okay, right side, orthocenter. So you guys remember back earlier in the module, this is the problem that I gave you guys a separate video, and I'll get you guys that separate video again if you want it. This is one of my weaknesses, but the orthocenter is the intersection of three altitudes. So the altitude runs from the vertex, and it's a perpendicular into that opposite side. There's one over here, just like over here. I want to find the orthocenter triangle below, and I keep working with it. I'm pretty sure that's it right here, but pretty sure it doesn't cut it, so we're just going to skip this for now. I will do a video just on orthocenter when I beat this little thing. So, all right, real quick, flipping over number 1. Find the measure of CD. So we're talking about this side over here. So we've got these two sides congruent. So this is an angle bisector. So these guys are going to be congruent. So to get CD, we've got to put these two equal to one another and solve for A, and then plug it into this side. So we have 3A plus 7 is equal to 2A plus 14. We're going to subtract 2A. I always start with the smaller of the two variables. I say this because I've had talked with some of you guys in class and just trying to get better at our algebra skills. So Got all this going on here as I'm talking. Subtract 7 from both sides. A is going to be equal to 7. We're going to plug in CD equals 3A plus 7, which is 3 times 7 is 7. 3 times 1 is, 3 times 7 is 21 plus 7. And so CD is going to equal 28. We kind of went over, but we needed to do that. All right, let's scoot up the page here. We're going to move a little quickly. All right, so if JK is congruent to MK, the length of JM is blank. Well, if these two guys are congruent, this is an angle, a perpendicular bisector. It's going to make these two guys congruent. Let's see. So if these two guys are congruent, this side is 6.2, this side is 6.2. JM is the whole. That's 6.2 plus 6.2, which is 12.4. Again, we were looking for JM, so the entire line. Excuse me. All right, flipping down here. Oops. Number 3, bottom of the page. Fill in the blanks with the available answer choices. Find the length of CB and the measure of MDA. I'm sorry, BDA, Lord, BDA. All right, so notice this is a angle bisector. Split this angle in half. So if this side is 26, then this side is 26. So your answer for the measure of BDA is 26 degrees. And then for CB, these guys are going to be congruent because with this being an angle bisector, it's equidistant to these sides. So we're going to say 3x plus 1 equals 8x minus 9. We're going to solve for x, and then they want CB, so we'll plug it into this. So subtracting the 3x leaves 1. 8 minus 3x is 5x minus 9 plus 9. 5x equals 10 divided by 5. X is equal to 2. Now we need CB, which was 3x plus 1. That's 3 times if x is 2 plus 1. That's 6 plus 1. So this is 7, which is right here. Okay, hope you guys caught all that. All right, moving on. Number 4. True or false? If G is the end center of triangle ABC, then GD is equal to GB is equal to GE. Okay. So the end center is equidistant to the 3 sides. So GD, that's one of those. GE, that's another one. GB, that's that one. So this is false because the other one is congruent to is GF. Okay, scooching down here. What are the range of possible values for x? So looking here, we have this angle to this side, this angle to this side. This side is bigger than this side, so that means this side is going to be bigger than that. That's going to be 3x plus 10 is less than 55, because 55 is bigger than, greater than. So we're going to do one side here. Subtract 10, subtract 10. 3x is less than 45 divided by 3 divided by 3. So x is less than 15. That's right here. And if you say 3 times 15, that's 45 plus 10, that's 55. Well, these two angles can't be equal. This one has to be bigger. So x has to be less than 15. Hope that part makes sense. I'll do this other side in another color. So here, we need this has to be greater than 0. And it's got to be greater than 0 because, that looks way jacked up, because the angle has to be at least 1. So we're going to say 3x plus 10 is greater than 0. We subtract 10. 3x greater than negative 10 divided by 3. Divided by 3. Got x is greater than negative 3.3. We're going to just round it there. So we'll say, yeah, we'll just say negative 3.3. If you multiply that in here, you're going to get almost 0. Can't get quite 0. All right, moving on. Flipping over. Yeah, that was number 5. So flipping over the next page, number 6. Got to back out. All right, so obviously it's going to be impossible for me to highlight everything. So we're going to kind of do these in color. So this is the measure of angle GCF. So GCF is this side. Well, if these guys are congruent, because you know those are congruent, these are congruent, because this splits these in half. So these sides, I mean, you guys caught that. Let's see, and if it's the in center, that makes this guy, and this guy all congruent. So they're all 3.9. So I don't think it asks for any of those sides on this one. So let's see. So GCF, this one side is 31. So the other side is 31. Let's see, where are we at next? CGF. So this side. All right, so for this guy, the whole triangle is 180. That one's 90, so subtract 90. This side's 31, subtract that. Oh, 1 second. So subtract them both out, and you end up with 59. 0.259. There we go. All right, DAG. DAG. So this side. All right, so we need to know this. All right, so let's do a little background math here. So angle B is going to be 21 plus 21, which is 42. Okay, now you see. The angle C is 31 plus 31, so that's 62. So this guy is 180 minus 42 minus 62. That's 180 minus 104, which is 76. So angle A is 76. Well, these guys are, if this is split in half, one's going to be half of 76, the other's the other half. Half of 76 is 38. So this side is 38, and this side is 38. Hopefully all this is making sense to you guys. So DAG, 38 degrees. All right, BGD. So we found another color. Hang on. BGD. So this guy. All right, so over here, 180 is the whole triangle. One's 90 because that side's 90, that side's 90. And then this side was 21, so that side was 21. We subtract all those guys out, we get 69 degrees. BGE. So BGE. So this side of this one. So again, We have a triangle with a 180 minus 90 minus 21. So same as this other one, it was 69 as well. There is no 69 on there. We had a misprint, but it should be 69. You see at the bottom of the screen there. All right, so last one, DA. I'm going to highlight this, DA. So notice DA is not the hypotenuse. That's across here. So the hypotenuse is 12.3. So that's your C squared minus your A squared. That's the 3.9. We subtract those out, take the square root, and you end up with 11.7. Okay. All right, flipping over. Number 7. Sunil is designing a triangle-shaped bird bath. A pole is attached to each bird bath to hold it up. Where should the pole be placed in order to balance the bird bath? So the center of balance, this is the, I think it's the circumcenter. Well, I just know how to solve it. It's late. All right, so the way we're going to do this, we're going to take the x's, all three of them divided by 3, and the y's. So it's going to look like this, x1 plus x2 plus x3 divided by 3. And then the same for your y's, y1, y2, y3 divided by 3. Different over here. So our x's, and it doesn't really matter because we're just adding 3 numbers together. So 2, 9, and 4. 2 plus 9 plus 4, 7, 7, 1. 7 plus 1. All right, so 2 plus 9 is 11, plus 4 is 15. 7 plus 7 is 14, plus 1 is 15. 15 divided by 3 is 5. 15 divided by 3 is 5. So there's your answer, 5, 5, which is 1, 2, 3, 4, 5, 3, 4, 5. It's right here. There we go. All right, moving on, number 8. Again, trying to be quick. Let's see. While playing a game, Jordan and Kyle start at the same base, then go and hide their team's flag. Jordan walks 32 yards east, so he goes 32 east. And Kyle walks 32 west, so he goes 32 west. All right, so Kyle turns 38 degrees and then goes another 30 yards. And Mr. Jordan here turns at 43 degrees and goes an additional 30 yards. Who's further away? So remember, bigger angle, bigger side. Smaller angle, smaller side. So if this is the bigger angle, this means over here that, so Jordan's angle is bigger, means Kyle's further away. Well, they want to know who's closer. So that's going to be Jordan. Just show, or try to anyway. So here, so this was Kyle because he went west, and this was Jordan. Smaller angle, smaller side. So that makes him closer to the base. All right, I'll do this real quick at the bottom. Number 9. Could each potential side lengths create a triangle? Yes or no? All right, so remember, 2 sides have to be, we're just going to write this over here. Any 2 sides must be greater than the third side of any triangle. So always take the 2 small numbers. So 3 plus 5 is 8. Since 8 is equal to 8, it has to be greater than. So this is no. 5 plus 7 is 12, which is less than 13. So that's a no. 2 plus 4 And 5 plus 7, I'm sorry, 2 plus 4, God help, 2.4 plus 5 plus 0.7, which is 8.1, is greater than 7.9. So this is a yes. 3.1 and 3.1 make 6.2, which is greater than 6.1. So this one's a yes. And then lastly, 18.23 plus 18.23 is obviously bigger than 18.23. This is also an equilateral triangle. So, of course, it is a triangle. All right, bottom of the page. Number 10, almost done. For the possible side lengths for LN. So, remember, get the third side here. This is going to be your two sides subtracted from each other. This is going to be your two sides added. So 25 minus 11 is 14. 25 plus 11 is 36. Easy peasy. All right, let's see. Okay, last two problems. All right. Excuse me. Let me zoom in. Make this quick and painless. All right, number 11. Location of 3 beehives in an apple orchard forms a triangle. Hive A is 788 feet from hive B, and hive B is 300 feet from hive C. Possible range of distance between hive A and hive C is blank is less than X, which is less than blank. So again, we're going to subtract the two numbers, and then we're going to add the two numbers. So 788 minus 300 is 488. 788 plus 300 is 1088. So there is your range. Number 12, last thing here. Fill in the blanks using the available answer choices. How do the length sides of JK and LM compare? Are they less than, greater than, or equal to? All right, so JK's over here, LM's over here. Notice this angle is smaller than this angle. So that makes this side less than that side. So JK is less than LM because this is a greater than, this angle is greater than that angle. All right, that does it for this time. Until next time, guys, have a good night.